Yeah, hi. So actually today it's cats on surfboards. So there's nothing better than multicolored themed, especially cat-themed socks. Well, maybe this talk is going to be better than multicolored cat-themed socks. Who knows? So yeah, as said, I'm Sebastian. People on the internet know me mostly as ASCII on Twitter and GitHub and basically everywhere. I will talk a lot about web video now, but this is not part of my job. So everything you'll hear from me in this talk is founded in a little side project of mine, because actually I'm working in the sector of IoT and smart home stuff, and yeah, but that has nothing to do with this talk. So yeah, you might have seen this wonderful title site full of abbreviations and letters and stuff that doesn't seem to make any sense, and probably thought, what the heck is this guy talking about? Well, the thing is, basically, when I first encountered all these cryptic words and abbreviations, I thought the same thing. But after I dug into this, I actually noticed I've used all the technologies mentioned in that title site a gazillion times, because mostly every time I watch a video on Netflix or Amazon or Sky or DAZN or something like that. And probably so have you. And I hope that after the next 40 minutes that those abbreviations won't seem as alien as they did just a minute ago to you anymore. But before diving into the topic of Netflix and DRM, etc., let's talk about the history of video on the web just for a brief moment, or as I like to call it, from QuickTime to Netflix in just 25 years. So it all started with QuickTime in 1990. So QuickTime wasn't used on the web or in a browser in 1990. That didn't happen until 93 or 94. But nevertheless, it kind of started all with this little software, this little video player. And it was amazing for its time. So it could play 156 by 116 pixel videos with 10 frames per second. And the thing was, it could do that without any hardware acceleration. So everything was done by the CPU. No extra graphic CPU, a graphic processor was involved or of any kind. And also, when it was used on the web, it could live stream videos with just dial-up connections that only utilized 9,600 baud. That's 9,600 chars that could be transmitted per second. And I've actually remember, like in '95, the first live stream I've seen on the net was a concert from a German pop group, and that was with a 9,600 baud dial-up connection, which was like barely a few kind of like colored pixel blobs moving around and extremely bad sound. But it did work, which was amazing for that time. And yeah, that was like, I hope some of you remember that, like the good old days of Netscape Navigator. And when you had a video back in those days, it kind of felt a bit off. It didn't fit the Chrome of the browser, the UI of the browser. It looked like some other program found its way into the browser to display that moving pictures. And the thing with this is, it was, because you use the embed element in some third-party technology like the QuickTime player, the real-time player, and all that stuff that was like up to date in the 90s to display videos on the web. So nothing native to the browser. That was also still true when Macromedia in '97 released the Shockwave player. It wasn't meant for videos back in '97, that only happened in 2002. And you know, Macromedia got acquired by Adobe, Shockwave player became the Flash player, and then it all went downwards. And yeah, the interesting thing is, so they introduced playback of videos back in 2002 by utilizing the so-called Sorensen Spark codec, the H.263 spec-based one, which is basically the predecessor of all the videos that we have today coded with the codec of H.264 and H.265. The interesting thing with the Shockwave player back then was it optimized the videos for small file sizes and low resolutions, so that you could use them in the early days of this decade or this century with your old dial-up connections and low bandwidths. This is actually a demo video, an original demo video from 2002 that they shipped with the player. It's the start of a Soyuz spaceship. And this video has a duration of 43 seconds, and it only has a file size of 560 kilobyte. There's also some audio in this video, which I'm not playing because it's quite boring. But think about it. Back in the day, you could actually fit 2 minutes of video in this quality on a floppy disk, which is also an amazing achievement. I mean, of course, you don't want to watch a movie or whatever with this kind of quality. And yeah, also the same thing as it was with the Shockwave player, as it was with the QuickTime player and the Real Media player, etc. It wasn't native to the browser. It was some third-party technology, some extra software that hooked into the browser to enable video playback. Well, enable it when it worked, and when you worked on Linux, it mostly didn't, and, well, all that shitty stuff that comes with, well, proprietary software in the browser. Of course, there were more solutions, also Microsoft Silverlight, short-lived, etc. But all of these solutions had one thing in common, and the thing was they were basically black boxes. So some alien piece of software that kind of like sat on top of your browser like a parasite eating out all the good. And that was the truth until 2007, when Opera came around and proposed the HTML5 video tag that we all love today, because we finally can have native video on our web pages. It's really sad, on a side note, to see Opera go as a company, and years ago as, well, the founder of its own browser engine and own JavaScript engine, because without Opera, the web wouldn't be as it is today. They contributed a lot, really a lot, to the evolution of the web, especially in the past 10 years. And yeah, it's just kind of sad to see them go. And also, they're the reason that we have the video tag in a browser. Which leads us to our present situation. Well, the video tag's the thing that we use to get moving pictures on our web pages. And just look at it. It's just a pure joy. It's easy, it's convenient, and the cool thing is it basically has a fallback built in. If you read the text, so if your browser couldn't understand the video tag, if your browser wouldn't be able to support the codec the video was formatted in, then you could say, hey, no worry, just download the video and watch it in your favorite video player. But hey, well, wait a minute. So what if I have videos people actually should be able to pay for, and me as a service don't want them to be able to download the videos just when they're watching them? So what do developers do? They ask Stack Overflow if there's a solution, and so did I. And the thing with this is you get a lot of recommendations. Oh yeah, you can disable right-click, as if that would help, like with developer tools and stuff. But yeah, that's the sort of stuff you get from asking Stack Overflow. The reality is, though, you can't prevent downloads from videos embedded with the video tag. It's just as open as it can get. Which is kind of a whoops thingy sometimes, because of course you don't want to distribute all the videos you have. You don't want to enable everyone to download them. So our lovely video tag is basically the complete opposite of the solutions we had before. Those were all black boxes. The video element was like open to its heart. You could always get to the source of the requested video, the total opposite of a black box. So the thing is, if you're on Netflix and you look at the source, and you see, hey, they're using the video tag. And Sebastian, you just said there's no way to prevent downloading videos when you use the video tag. Can I just like right-click and save Netflix? And the thing is, of course, no, well, you can't. Otherwise, the whole business model of Netflix would be completely destroyed. And the reason for that is digital rights management, DRM. Or depending on the people, on the groups of people you ask, they would call it digital restrictions management. I'm totally fine with both terms. So, what's this DRM thingy and what does it do? DRM itself is not a single technology. It's not like a piece of hardware and not a piece of software you just install and use. It's more like an overarching term for things like authentication, user or content-specific encryption, key and license management, all the things that you need when you want to distribute content. One thing here that is the second to last bullet point is very interesting, forensics and data tracing, because this is one of the core things that DRM does. It enables providers to trace who, well, downloaded a video or maybe made a copy of it somehow, redistributed it, so they could actually trace down to the account the video was initially requested. This is one of the core things. And to understand DRM itself, we have to take a look at the ecosystem stakeholders of DRM, and there are quite a few. So content owners, those are typically the companies that either produce content or license the content from producers. So for example, if you, hey, we're in Croatia, you probably remember this year's World Cup, do you? So the FIFA, for example, is a content owner. They originally produced the content, the video streams, the live streams of the football matches. So that makes them a content owner. They can license their content to TV stations and also for online publications. Those companies who produce those contents are basically the strongest force in the whole DRM ecosystem. Then you have, of course, the DRM cores, which are the companies that provide technology for DRM, which are companies like Google, Microsoft, Apple, you name them. Well, there are a couple of few ones more, tinier ones, but actually Google, Apple, and Microsoft control over 90% of the DRM ecosystem when it comes down to the actual technology. Service providers are also in the game. Those are the ones who build up the software or services to encrypt videos in the first place. We have the browsers, which are there to play content. Content providers like Netflix, Amazon, Sky, DAZN, etc. They also have a tiny part in this game. Well, they ship those content to you, the users, but they're not as powerful as the content owners, as we'll see later on. And also there are device and chip vendors, because there are actually ways to implement DRM in hardware form, and technologies or devices like sophisticated Android TVs, etc. do this. So also these device and chip vendors have quite a part in this game. So yeah, knowing that, I don't know how many of you use Netflix or Amazon Prime or services like this at home? Quite a few. So have you ever noticed that when you watch a video in your browser, that it has an extremely bad resolution, like it's just SD resolution, but then you switch over to maybe your mobile phone or your Apple TV or your Android TV, etc., and it plays perfectly fine in 4K resolution. It's like they're on the same network. It's not a bandwidth issue. You go back to your computer and take a look at your browser, and you end up with SD quality again. And I don't know, it's like, that's a mystery. Yeah. It's the same network, basically same account, my devices at home. And the reason for that is called trusted environment robustness. The thing is, there are 3 different ways videos can be decrypted with DRM technologies: software, hardware-assisted, or full hardware. We'll get to that in detail in a minute. The thing is, if you use Chrome or Firefox at home, you only get software decryption for big companies like Netflix or Amazon. You use all of the decryption will happen on your CPU, and actually, software decoding is considered less secure. So the content owners, the companies who produce the content, actually then tell the content providers, companies like Netflix, that they are not allowed to ship high-quality content in case of software decoding only. So it can happen if you have a Windows PC or a Mac and you use Chrome for like playback of Netflix content and switch over to Safari or Microsoft Edge, that you can, well, view your content in a higher resolution in Safari and Edge, because Safari and Edge have, well, the advantage of being tightly coupled to the operating system, and the operating system actually can use hardware-assisted decryption. So, also can, of course, things like the iPhones, don't have it in my pocket, oh, it's over there, and Android phones, because the DRM is baked into the operating system, or even better, especially, which is correct for the Apple TV, or, as I said, for some Android TVs, the DRM is baked into the chipset itself. So there's some extra processor decrypting the content. And that is for hardware decoding, which is considered the most secure way, because you regularly can't tap into the chain of decrypting and grabbing the video materials. So the thing is, content owners, they want to make content piracy as less attractive as possible, enabling in insecure environments like software decoding, where piracy is most likely, making it unattractive by just shipping low-quality videos. And of course, this is just a rule of thumb, because Netflix itself doesn't care that much for their own production series, like, I don't know, Star Trek Discovery or BoJack Horseman or anything like that. You get that in full HD quality also in a browser, because Netflix says, well, actually, we don't care with our original series. But especially many big old movie studios, they really care, and you only get those movies in SD quality. And if we take a look at DRM calls in browsers, you see what I meant when I said that over 90% of this ecosystem is controlled by Apple, Microsoft, and Google, because Apple uses their FairPlay DRM, which was initially generated or invented for the first iPod generation, and they just evolved it over time. Microsoft used a new DRM technology, which they call Play Ready, which is the successor of the former used in Silverlight used DRM technology, Smooth Streaming. And then it gets interesting, because Chrome and Firefox, they use a technology called Widevine. Widevine is a company that is owned by Google. So the thing is, every time you watch a movie with Firefox, you're actually using Google technology in the background, completely transparent to you as the end user, to watch that video. That is actually a glimpse into the Firefox source code, which is open source, and you can see some URLs where you can actually download for your operating system or system architecture that software decoding and decrypting library from Google. Because Google doesn't allow vendors to ship that library with their software, even not Firefox, even if they want to have it in there. Every time, so the first time you'll actually watch a movie in Firefox, what happens in the background is that this library gets downloaded from the Google servers. It's like 2 to 3 megabytes, you barely notice, and then the video starts. And then it's basically in place in your system. And every time you watch a movie with Firefox, you use this Google technology. So the library you can download here is actually called a CDM. CDM is short for Content Decryption Module, which is a piece of software hardware. As said, DRM can also appear in a hardware form, and it does the decryption for you. Maybe it also does the decoding for you and just pass the raw video frames back to the browser. That is actually up to the content provider to tell the CDM what it should do. If it just should decrypt and let the browser render its thing, which is kind of insecure because you pass some data the browser actually needs to interpret, and you can tap into that rendering chain. And what most companies do is they say, okay, we use the CDM to decrypt and decode the video directly, which also has a performance impact because it's just software decoding and decrypting, at least in Firefox and Chrome, which means everything is done by the CPU. And also from all of the tests that I've done, it's limited to 2 threads or using 2 cores in parallel. So you can have an 8-core machine, but your CPU will just utilize 2 cores to render that, which can be a bit puzzling if you want to do things like I did, where we will get later to actually run such a thing on a Raspberry Pi, which is kind of a low-power device. But yeah, the thing now is, how does this all play together? So let's take a look at the browser decryption and decoding layers. So when we have, let's say we are a content provider like Netflix, what are the different parts that we utilize to play video? Of course, we have our JavaScript application. That is the thing that we write, that we have under control. We have the browser, which is like the thing we need to do the playback for us. We use the content decryption module, the CDM, the thing I just explained, to do the decrypting and maybe the decoding for us. And then below that, we have like the DRM basis. I couldn't find a better term for this, so I just called digital rights management again over there. This is where all the weird crypto shit happens that I really don't have a clue of. It's like, that is hidden behind many walls and hidden behind NDAs, and it's really hard to get a hold on that one. So like really the core, the cryptographic stuff. In DRM terms, that means our JavaScript application and our browser are called the DRM player. The content decryption module is called the DRM client, and everything below that is called the DRM core. So this is the official terms that they use. We'll go and focus on the player. This is what happens when you play a video in Chrome or Firefox using Widevine. It's kind of similar for every DRM, and also quite a high-level picture. There's a lot more going on under the hood, but this is the rough overview. And yeah, when I first did draw this picture, I found it a bit confusing, so I think we should go over this step by step, because I can only imagine that you might find this a bit confusing as well. But first, real world. How can we apply this to the real world? Let's do a quick demo. So, I mean, let me quickly turn on mirroring. Here we go, and open up my Chrome. And what we're going to do now is we're going to play, okay, I'm connected, good. We're trying to play a video from Netflix outside of the Netflix UI. So there's a bit of stuff happening here, and if we're lucky and everything works, it's also, if I'm not at home and don't use a VPN, it's always a bit like gambling if it will work. But yeah, it works. So anyone can guess the movie? Great. But sorry, I don't have any prizes with me. Yeah, so that is happening. That is playback from Netflix on, well, my local machine. So this is on my local host, not within the Netflix UI and a lot of gibberish. So this is an application I wrote to debug, well, the whole stuff that is happening behind the scenes and actually get a hold on what Netflix really does when they deliver a video and what happens in the client in the browser. And we'll continue with the presentation because I'd like to tell you how I got that far, how, well, accepts of the code look, and how I actually, well, tackled this reverse engineering of the Netflix client. So, what we have here, oh, sorry, I have to turn off mirroring again quickly, because otherwise I'd be lost without my speaker notes. So, what we see here is all of the requests that Netflix does when you are trying to play a video. So I did the thing that seemed natural to me as a developer when I started reverse engineering. I just popped up my developer tools and see what requests are happening when I play a video. And it's a shitload of, well, requests. And I thought, oh, I have no idea. I will never, ever know what these things are used for. But I actually found out quite quickly that you only need those 3 requests to play a chunk of video. So the rest is basically analytics, preloading trailers, reporting some stuff, and some debug and log things Netflix gets from the clients. So yeah, that's all that's needed. We have the manifest. We need a license to, well, be able to play back the video, and we need a chunk of video that we want to play. So let's get into the actual code. But first of all, fair warning. The Netflix player code consists of 76,000 lines of JavaScript. And what you will see on the next slides are, of course, not 76,000 lines of JavaScript. It's like the boiled down version, which illustrates the concepts, but if you would just write it down like I did on the slides, it would not immediately work. It's just there to illustrate how things work and how the browser APIs Netflix utilizes do look. So yeah, that's our boilerplate code. We'll have, in the end, 3 functions that we'll use that enable us to play a video. Some configuration, something that's called media key system, and a media key session. We'll get to each of them in a minute. But first, you need to you need to know about a browser API that was introduced in 2013. EME, the so-called encrypted media extensions. It's a very, it's a very dumb API because it doesn't do anything on its own. It's just a JavaScript interface to the content decryption module. And with the content decryption module, we can access the key server, the license server, and the video data packaging service. So kind of like the content delivery thing. It doesn't do any like decoding, decrypting itself. It's like really no magic. It's just an interface to the content decryption module that we use. In our case, Widevine, because we're sticking to the Chrome and Firefox example. So yeah, let's start with the key system configuration, which is just, in this example, here, a JSON object, which doesn't do much things. So in Netflix code, in Netflix JavaScript file, that thing is about 1,000 lines long because it's highly dynamic and it does for every Chromebook or everything, compile the config on its own. But as my target is Chrome only, I can say, yeah, I just know what Chrome can do. For example, hey, I can have, if I want to, theoretically hardware secure decoding, because Widevine actually does support that. But I also can do software decoding as mentioned below. So all I have to do is I tell the CDM what my player, what my browser is capable of doing playback for, audio and video wise. Well, that was the first function. Next one is the media key system. And this is where things get a bit more interesting. So this is actually the part where we're interacting with the content decryption module, using the navigator request media key system access method. That's a method name. Whew, they probably just stole it from Java. I don't know. No, maybe then it would be a request media key system abstract factory impl. I don't know. Sorry, no bashing. I just don't like fancy Java much. So yeah, what we actually do is we apply the config we've created, and also we say, The CDM that we're going to use is the Widevine CDM. That's just the namespace, Widevine Alpha it's called. Next thing we do is we need to, when we created those media keys using the browser API, we need to set a server certificate, at least for Netflix. This is not, well, optional, but mandatory for Netflix. Every provider can, well, tell if that's needed or not. But we need it for Netflix, and that was the next thing that hit me. It's like, where do I get that server certificate for the licensing server from? I have no idea. I didn't find anything in the requests. And then I found it in the Netflix JavaScript file encoded in base64. It's just a text string that never changes. I just copy it out in the text file, and it worked. Still the same after 2 years. So yeah, we needed that one. And then we needed to apply the media keys that we've generated using the browser API from the content decryption module to our actual video tag we want to use for the video playback. That was the second function. So up on to the last. Next thing we need to do is create a media key session. And that session is basically, well, exactly the same as a session when you use an online shop, for example, and have your shopping cart filled with stuff and go back, etc. But instead that it is a session with a remote server, we have a session established with the content decryption module. And that session is then valid for exactly playback of one video. That's the thing. So we have a session for one video established, where all of the data goes from, and that session is kind of validated from that CDM black box. So the next thing that we need to do is to generate a license request. And we can do that with a browser API method from the key session that we generated, which is called generate request. So CENC, what you see here, is abbreviation for common encryption, which is just some encryption standard they use for the Widevine system, which is actually widely used by other DRM systems as well. It's an ISO standard. And yeah, we populate that with our init data, which we get from the so-called encrypted event later on. So this is all stuff that happens in the CDM, and we just need to pass the data through. So next thing is that we have the handle message callback here for our key session event listener. And this actually then lets us write our code that we can fetch the license from the license server. So we send up just generated data from the content decryption module using a plain old AJAX request to the licensing server. We get back another blob of binary gibberish, not worth taking a look into because it's just really some binary gibberish. And we need to update our key session with that, and that is then the actual license that we need. If we apply that to the picture you've seen before, so first thing we need to do, JavaScript app says to the browser, hey, I have a license request. Browser says, okay, CDM license request. CDM says, okay, validated, session established, license request goes back to the application. Application then requests the license from the license server and then passes it back on to the CDM. Well, thing is, after all that trouble, we haven't played a single second of video yet. So that was all the things we need to do before. Because to play actually video, we need utilize another browser API, the media source extensions. Also, not some witchcraft. All it is a programmatic way to access the video element. So instead of defining a file, a source file, in the video element itself, we populate it with data we request from JavaScript. So also completely unrelated to DRM itself, because you can utilize this for all your audio and video fancy projects you want to use in your browser. But yeah, we can also use that to apply the chunks of video we get from our content delivery network, the DRM videos itself. Not going to dig deeper into that code, to be honest. All we need to do is create a media source and then tie that to the source element of the video. And for the sake of simplicity, I just have some random array with chunks of video I load, and then I'll apply to the so-called source buffer and to the video element itself. So just some plain old XHR requests, and we're good to go, requesting some chunks of video and applying them. As said, so there are some more events. We also need to specify the type of video that we're playing, etc. Not so interesting. More interesting is what happens then. So we have the CDN, we have the encrypted video chunks. The browser or application sends it to the browser. The browser uses the media source, encrypted media extensions to talk to the CDN, and then all the data that gets pushed back, we use that to actually have the moving pictures on our video element. Question here is, when does the browser know which chunks to load when? And that is, well, that is the topic of the manifest. If you remember the three requests that are actually needed to play video, one was the license, the other one was the video chunk itself, and the third one was the manifest. To request the manifest from Netflix, we also need to apply some configuration. Again, we need to tell them which DRM system we're using. Very interesting, we need to tell them profiles. So profiles is basically us requesting data in the manifest in the index file to be listed. So we can say, hey, we want to have stereo audio, we also want to have Dolby Surround audio files, and we want to have high-res video, etc. It's not a guarantee that we actually get those chunks, but we can politely ask for everything, for every profile that we know, higher resolution video, etc. Most commonly used for such a manifest is the MPEG- format, an XML-based format, which actually has one neat feature. I don't know if you ever watched, like, on your mobile phone while you were on a train or on the move, a video, and you noticed that the playback continued, but your video got blurry or pixelish, and later on, maybe if your bandwidth was restored and getting better, the video was back to its full old quality. That is a feature called adaptive bitrate switching. And that is a neat thing when you transmit a video in tiny chunks of maybe a minute or 30 seconds. You can adapt to the environment the user is in. And if the connection of the user drops, you can send low-res video down the wire. Don't interrupt the playback, just make the playback go low resolution for the time the user has actually bad bandwidth. That's called adaptive bitrate switching. A manifest itself, it's, as said, just an XML file where you get lined up all the codecs, the videos, and the subtitles you can use in a video, and also information about the duration of the video, which robustness level, here we are again at the DRM side of things, is needed to play that back, and also then the actual video chunks itself. So this is one of the original URLs that Netflix uses, and this is like the range indicator. It's not seconds or milliseconds, it's some arbitrary format of time that Netflix uses to tell which part of the movie or series you're watching that actually is the chunk of. So yeah, basically that completes our picture. We just added the manifest, which can be served from the licensing server or the CDN extra, doesn't matter, and then we know which part of video we need to load. So with this, information, you're basically able to build a player for every video network out there. Well, of course, there's some authentication, etc. But because Netflix, I hadn't reached my goal of building a Netflix player. Netflix also uses something called message security layer. They call it MSL, it's invented by them, nothing to do with DRM, but they invented their own network encryption because they said HTTPS is too weak for them. So they serve everything over HTTP and have their own encryption format, the message security layer, and basically they use that to encrypt every data that is sent down, which then JavaScript is needed to decrypt because, well, if you want to know more, they wrote a blog article on that. The cool thing is, for me, reverse engineering this, they also have the Java server implementation and also the JavaScript client implementation of MSL up on GitHub, open source. So I could basically just copy all the stuff from Netflix itself. I needed to build this. This is on my GitHub, AskIDisco plugin Video Netflix. It is a plugin for the Kodi Media Center because I didn't want to take care of the rendering part of things. And to my knowledge, this is the only open source Netflix player that is out there. So if you want to watch Netflix movies, but, well, don't want to be tracked by Netflix, you can use this. It also runs on a Raspberry Pi. So low power hardware on a Raspberry Pi 3, even with HD quality. So that was quite an achievement in the end. Don't look at the implementation. I've learned Python along the way, and it's rather rubbish. But it works. I mean, that's the Python way, isn't it? Code looks rubbish, but works. Okay, so now I've upsetted Java developers, and I've upsetted Python developers. Who else can I upset now? Oh, that's so easy, I'm sorry. So back to our main topic. The thing is, we turned our lovely video element back into a black box because we use some third-party software, in many cases provided by Google, that sits in the back, and all of our data needs to go through this. Which I don't say they do. What Google could do with that is, even if you're using Firefox, they could track all the videos you're watching, regardless of if you're doing it on Amazon or Netflix or wherever, or some maybe XXX pages, I don't know. So they could theoretically track this. I don't say they do. I mean, that's Google. They probably won't have the resources for that. You know, they probably even won't think of that. But yeah, that's the thing. We have a black box again. Shit. What does the inventor of the open web, the internet itself, Sir Tim Berners-Lee, say about it? Of course, he's like pushing the open web, so he must be against this. And he said, so in summary, it is important to support encrypted media extensions as providing a relatively safe online environment in which to watch a movie, as well as the most convenient and one which makes it a part of the interconnected discourse of humanity. Where I say, well, somebody took something before saying that sentence, maybe? The interconnected discourse of humanity, some very bold words. And in 2013, when actually all that encrypted media extension stuff got standardized from the W3C, the Electronic Frontiers Foundation, which is a founding member of the W3C, which is led by people like Wozniak, etc., they also issued a statement. They left the W3C and they said, we were disappointed to learn that the W3C had taken the project of standardizing encrypted media extensions, an API whose sole function was to provide a first-class role of DRM within the web browser ecosystem. So we'll keep fighting to keep the web free and open. We keep suing the US government to overturn the laws that make DRM so toxic, and we keep bringing the fight to the world's legislators. Well, 5 years later, nothing happened, but still, bold move, bold words. The thing is, I can't tell you what you should think about this. I don't even know if I made up my own mind about this. I know we need video behind a paywall, business depend on it. I know that how it is done right now is very toxic. It is open to companies like Google being able to track every step you make in the web. It is a shitty situation at the moment. And all I can say is please make up your own mind and find your own place in this game of pro or contra DRM. Thank you very much, and enjoy the rest of the day.